Okay, so this video, I'll try to make it short as I can, is just going to kind of be the intro to stoichiometry. So this is starting Unit 9. So it's important to know when we say stoichiometry, what are we really talking about? So basically, all stoichiometry is it's just trying to figure out if I start with these certain ingredients, how can I measure all of these other ingredients that I have, or how do I know how much I can actually produce in my chemical reaction? So it's just like, if you're going to make, if your recipe says, oh, I need all these ingredients, and it says at the end it can serve 12 people. Okay, so you know that if you need to serve 24 people, then you're going to need more than your ingredients that you start with. Okay, so that's kind of all we're really talking about when we're talking about stoichiometry. We're going to look at some chemical equations, find out what we're starting with, and just find out how much can we make of our products. So basically, this is a very basic example of how it works. I know that if I'm going to make a grilled cheese, I need 2 pieces of bread, and I just need 1 piece of cheese. So if I look at my little example down here, right, if I want to make 7 grilled cheeses, okay, and I want to know how many slices of bread I need, well, I know that for every 1 grilled cheese, I need 2 slices of bread. So I put my grilled cheese on the bottom so that they'll cancel out. So I'm left with my slices of bread. So I'm just going to solve that by 7 times 2. So I know I'm going to need 14 pieces of bread to make 7 grilled cheeses. Okay, so that's basically all we're doing here. We're just looking at amounts of compounds instead of bread and cheese. Okay, so here's a real example. We'll just kind of look at it. And we're going to set it up exactly the same way that we did with our bread and our cheese. So I'm saying I want to make 10 moles of ammonia, NH3. Okay, so how many moles of N2 do I need? So just like in my bread, on my grilled cheese, I know that I'm going to cancel out. So down here, I know I need my moles of NH3. Well, where did I find my numbers that go in front, right? Those are my coefficients. So I'm just going to look and say, okay, well, what number's in front of NH3? It's a 2. So that's saying that for every 2 moles of NH3, and since I'm looking for moles of N2, I'm going to look at the number in front of N2, which is just 1. So I only have 1 mole of nitrogen for every 2 moles of NH3. So when I calculate, those are going to cancel. So basically it's just 10 times 1 over 2, right, which is just 5 moles of N2. Okay, so all I've done is I've just kind of looked at like a recipe. If I have for every 2 of these, I need 1 of these. It's like every 2 cups of flour, I need 1 egg, or something like that. Okay, so it's kind of like your instructions. The first thing we need to make sure we understand is balancing equations. So if you're still struggling with that, I suggest go back and look at some of the previous assignments. Watch maybe a few videos. You can find some in the slides for Unit 8. There's some YouTube videos that you could probably watch to kind of give you some other help. But we have to make sure we have our balanced equation because we have to know our coefficients. Same thing that we always do when we're doing this is we always want to start with what we're given. Okay, and we need to make sure we know what we're looking for. So there's a term here, mole ratio, and we've already been doing mole ratio. That's what you just did when we're talking about how many pieces of bread do I need to make a grilled cheese, right? You said that, well, for every 1 grilled cheese, there's 2 pieces of bread. That's your ratio right there. All we're looking at, or we're just looking at those coefficients in front of our elements, okay, to get our mole ratio. So let's look at an example. Okay, so for a mole ratio, let's say I want to know how many hydrogens there are to oxygens. Well, I'm just going to look and say, okay, well, in front of hydrogen, there's a 2. And in front of oxygen, There's 1. That's a mole ratio. Okay, what if I wanted to know oxygens to water? Okay, well, I'd look again in front of oxygen. There's a 1. In front of water, there's a 2. Okay, what if I wanted to know water to hydrogen? Well, there's a 2. In front of hydrogen, there's a 2. Okay, so for our sake, since these are going to be kind of set up inside an equation, it's fine to leave it as 2 to 2. You can go ahead and cancel it out if you want to save what you're typing in the calculator. You can reduce it, but it's important that we do write it down first as 2 to 2. And then you can reduce it once you get ready to calculate, to type it in your calculator. Okay, here's one that you can try if you want to pause the video. You can practice balancing the equation real quick, and then you can practice writing a few different mole ratios. So if you want to, pause it. If not, you can just kind of watch. I'm just going to go through it pretty quickly and just balance it out and then write a few mole ratios. I'm not going to write all of them, but I'll write a few. So notice it doesn't matter if I'm comparing things on the reactants versus the product side. It doesn't matter if I'm comparing, like here I have calcium on the top, here I have calcium on the bottom. It doesn't really matter. It's just a comparison, basically. How many moles per this many moles. All right, so here we have what we call our stoichiometry map. This is kind of like your stepwise process, just like we had our mole map where we could go from, mass to moles or moles to molecule, right? Our stoichiometry map is kind of like we put 2 mole maps together. We're not going to worry about volume, so we can just kind of cross that out right there. But basically what it's saying is if I have a mass of some kind of given substance here, if I want to find the mass that I can produce of my unknown, I'm going to have to use this mole ratio to kind of swap between what I'm given and what I'm looking for. Okay. If you look at the weekly plan, there is a little printout that you can print out. I think it says like foldable, Stoich map foldable. You can print that out. That kind of helps you set up and follow this map in the correct direction. If you watch the homework video, I kind of show you how to use it. So I'm going to just come do a little practice here. So what am I given? Well, I'm given 3 moles of calcium. So I'm just going to set up my train tracks. Okay, so what do I know right off the bat has to go on the bottom? I know it has to be moles of calcium. Okay, and I'm looking for moles of calcium chloride. Okay, so right here, this is where I'm going to put that mole ratio. Okay, so how many moles of calcium do I have in my equation? I just have 1. How many moles of CaCl2? I just have 1. Okay, so if I type that in my calculator, my answer, right, these cancel, end up just being 3 moles calcium chloride. So that is my final answer. So all this is saying is that if I start with 3 moles of calcium and I put these substances in a test tube and react them, then at the end I should end up with 3 moles of calcium chloride. That's all I've done. It's like a recipe. If I start with this many eggs, how many cakes can I make? Okay, that's all we're doing here. Okay, so here's another example. Again, I'm always starting with what I am given. 5 moles, that's a 0. Okay, so I know that on the bottom, I know I have to have moles of lithium chloride. Okay, and I'm looking for moles of lithium. So now I'm just going to look at my ratio. How many moles of lithium chloride do I have? Well, I have 2. How many moles of lithium do I have? Well, I have 2. Okay, so here, now I know that these 2 moles cancel out here. So I'm left with moles of lithium, which is what I'm looking for. And then I'm just going to do 5 times 2 divided by 2. So again, I kind of end up with the same thing. Okay, so this is just saying if I start with 5 moles of lithium chloride, I'm going to end up with 5 moles of lithium. Okay. All right, so this one, we're going to actually have to do some calculating. Okay, so again, if you want to try it, if you want to pause here and try it before I keep writing, go ahead. So I'm just going to start with what I'm given. 25.5 moles of lithium chloride. So I know on the bottom, I have to have lithium chloride because I always want it to cancel out. And I'm looking for calcium chloride. So I'm just going to look here. What number's in front of lithium chloride? A 2. What number's in front of calcium chloride? A 1. So this time I'm going to have to actually type it in my calculator or do it in my head, either way, and decide, because I can't just, these aren't going to cancel out like they have in previous ones. So when I type that in my calculator, I get 12.75 moles of calcium chloride. Okay. All right, this time we're going to look at starting at grams. Okay, so this might be, if you need to look at the mole map, I'll kind of write it down here. If you've printed off, or you can just draw it on a piece of paper, a little foldable. So if I have grams, I have to convert it to moles of my given or my known, and then I can convert it to moles of my unknown, or what I'm looking for, which in this case is calcium chloride. So I'm going to start with what I have, 70 grams of calcium. Okay, so what do I know has to go on the bottom? Grams of calcium. So if I look at my periodic table, which again is in the back of your lab manual, I think it's page 148 maybe, or 145, it's one of those. We have 40.08 grams of calcium. Remember, my molar mass is how many grams is in 1 mole of calcium. Anytime I'm going from grams to moles, it's always going to be 1 mole. Okay, so that takes care of my grams. Now I'm in my moles of given. So now I can go to my moles of my unknown. So how am I going to do that? I'm going to use that mole ratio. So I'm going to look up at my equation and I'm going to look at those coefficients that are in front. So I know my moles calcium's going on the bottom. Moles calcium chloride's going on the top. Okay, because I want them to cancel out. So I'm going to look. Calcium. How many moles do I have in my equation? Just 1. Calcium chloride. How many do I have? Just 1. Okay, so my grams calcium have canceled. My moles calcium have canceled. Now I'm left with moles calcium chloride, which is what I wanted to find. So now I'm just going to type it all in my calculator. And luckily, just makes it easier on me this time. My 1-to-1, I don't really have to worry about that. So I end up with 1.75 moles of calcium chloride. Because remember, in the lab, we can't actually measure moles, but we can measure grams. So you're going to see grams a lot. Okay. So here's another practice, just like the one we just did. If you want to pause, kind of look at the last one, how we set it up, you can do that here. Okay, so remember, if I'm gonna, before I can go from my moles of unknown to my moles of known, or between my moles, between my compounds, to get from lithium chloride to lithium, I'm gonna have to go convert my grams into moles. So how many grams of lithium chloride are in 1 mole of lithium chloride? Right, I have to add those up. So lithium is just 6.9, chlorine is 35.45. So when I add those together, I get 42.35. Okay, remember that's how many grams are always in 1 mole. Now I can look at my mole ratio. Now that I'm in moles, I can look at my mole ratio. So I know I need lithium chloride on the bottom because that's what's on the top. And I'm looking for lithium. So let's look. I have a 2 in front of my lithium chlorine, and I have a 2 in front of my lithium. So I'm just going to type it in my calculator. Multiply the top, divide by the bottom. So I end up with 0.649 moles lithium. Okay, and like I said, if you printed the foldable, you can actually fold it, where if you're starting with grams of your given and then you're trying to find moles of your unknown, you can just like kind of fold off the excess that you don't need, and it shows you exactly how to set up this whole thing right here. Okay, and like I said, if you watch the video for the homework, that'll kind of help you too, because it'll kind of show you how to use the foldable in the video. Okay, this one is just one step past. If you want to pause it and just see if you can go all the way to grams, if you want to just watch what I do again, I'm just going to kind of write it out. So I'm starting with 30 grams. Okay, so in this case, right, I can't use my, if we think about our mole map, I can go from my grams of what I know to my moles of what I know. Okay, and then in order to get here to my unknown, or what I'm looking for, moles of, we'll write unknown. Okay, I need to use my mole ratio. Okay, and then I can get to my grams of my unknown. So if I have grams, I'm right here, grams of my known to moles of my known, I'm going to use my molar mass. So this is the one that we just did. So it's 6.9 plus 35.45 is 42.35 grams lithium chloride. Okay, remember my grams is always equal to 1 mole. Don't let that get confusing. If you look at the foldable that I gave, it always has a 1 right here, because that's always 1 mole to grams, right? That's just like our mole map. Only time you're going to have different numbers is when we get over here to our mole ratio. Okay, so I have my grams of my known. Now I'm at my moles because I converted it. Now I can use my mole ratio. So I know I want moles of lithium chlorine on the bottom because that's what needs to cancel out. And I can do moles of calcium chloride at the top. So let's look at my equation. I have 2 and I have a 1. So I've done my mole ratio. I've got my moles of my unknown. Now I can convert to my grams. So this is kind of back to what we've done before, right? Just like at the beginning. How many grams of calcium chloride are in 1 mole? So I'm just going to add it up. Calcium is 40, and then I've got 2 chlorines. So total, that is basically 111 grams. Okay, so now I've done all of the above. Now I can just type it in my calculator, multiply all the way across, divide by the bottom, and you should get 39.3 grams calcium chloride. So that's my answer. So basically, if I was in the lab and I had 30 grams of this lithium chloride and I performed this reaction, if I weighed out how much calcium chloride I produced, it would be 39.3 grams. Okay. So feel free to go back through that video however many times you need. Make sure today you go through and look at the homework for 9.1. Again, watch intro video. Okay, I show you how to use that little foldable, and I kind of show you how I've given you kind of the setup for some of those problems, so you're not having to do it all from scratch at the beginning. So watch that video first before you do it. And again, if you have any questions, let me know. If you need to do a Google Meet, if you need some more help or anything, again, just email me and I'll try to get back to you as fast as I can.